Yes, welcome back. I made a small bowl of candy. Just record a bit video and then it's uploading. So actually I'm finished for today, but I need to put memory cards to my old Canon. I like to read this Wafer. It's 10:20 p.m. Let's take some juice and not drop my memory cards. Actually, I dropped some water on it. Camcorder. Put a bit of water, I think. Not much. But I'm done for today. I just like to read a PDF one more, then watch Netflix. So when I'm charging this, I have power for like 1 hour, but I think I should try to get a little bit more sleep tonight again. That was my plan. Finish upload the semiconductors. Let's take some lemonades. So it's just Friday, is the last weekend in a long month. I'm out of money, and Wednesday I will get my pension in like 5 days. I weighed my body weight today, and I lost 1.2 kilos to 98.6. But I'm still very heavy. I have to go below 90 kilos. But I've been much bigger. Last summer probably I was like this, much bigger. But I'm still very close to 100 kilos. I'm still very heavy. So it's been a long hot day and it's still very hot. It starts to getting a little bit dark more early because it's September. Next week it's September. It's 29. It's 29 degrees, close to 30. So it's still very hot. Let's close the blinds. I would like to close the door, but it's so hot always. I will have to close the door soon. But it's Friday evening. This is Friday evening, not many go to bed 10 p.m. and we're not going forward, so let's yes, so I'll just start read this Wafer and eat this candy. That's 12 pages. So let's do that. And it's 8:30 soon. I think maybe just read this and then I stop. But there's a long list of PDF I like to read. All this about memories. I have a long list. The E in debit RAM, dynamic random access, DRAM, and static random access memory, SRAM. synchronous dynamic random access memory, SDRAM, double data rate synchronous dynamic random access memory. That's used for memory inside the computer, DDR, SDRAM. We have in DDR the second generation, and third, 4, and the new one, the 5. The 5 is there. I have to drag it to there. That's the new one. Microcontroller, vacuum tube computers, vacuum tubes, transistors. That's 70 pages, John von Neumann. So that's old computer, that's old CPU and supercomputer. So I don't think even the whole weekend. So let's start.
Wafer, electronics. Top, polished 12 and 6 silicon wafers. Their crystallographic orientation is marked by notches and flat cuts, left. VLSI microcircuits fabricated on a 12-inch, 300 mm silicon wafer, before dicing and packaging, right. Bottom, solar wafers on the conveyor, left, and completed solar wafer, right. In electronics, a wafer, also called a slice or substrate, 1, is a thin slice of semiconductor, such as a crystalline silicon, Si, used for the fabrication of integrated circuits and, in photovoltaics, to manufacture solar cells. The wafer serves as the substrate for microelectronic devices built in and upon the wafer. It undergoes many microfabrication processes, such as doping, ion implantation, etching, thin film deposition of various materials, and photolithographic patterning. Finally, the individual microcircuits are separated by wafer dicing and packaged as an integrated circuit. Contents. History. Production formation. Cleaning, texturing and etching. Wafer properties. Standard wafer sizes. Silicon. Historical increases of wafer size. Photovoltaic. Crystalline orientation. Crystallographic orientation. Notches. Impurity doping. 450 mm wafers. Challenges. Analytical die count estimation. Compound semiconductors. See also. References. External links. History. In the semiconductor or silicon wafer industry, the term wafer appeared in the 1950s to describe a thin round slice of semiconductor material, typically germanium or silicon. Round shape comes from single crystal ingots usually produced using the Czochralski method. Silicon wafers were first introduced in the 1940s. 2, 3. By 1960, silicon wafers were being manufactured in the US by companies such as MEMC /Sun Edison. In 1965, American engineers Eric O. Ernst, Donald J. Hurd, and Gerard Seeley, while working under IBM, filed patent US 342362904 for the first high-capacity epitaxial apparatus. Silicon wafers are made by companies such as Sumiko, Shin-Etsu Chemical, 5, Hemlock Semiconductor Corporation and Siltronic. Production. Formation. The Czochralski method wafers are formed of highly pure, 6. Nearly defect freezing or crystalline material, with a purity of 99.9999999%, 9N, or higher. 6. One process for forming crystalline wafers is known as the Czochralski method, invented by Polish chemist Jan Czochralski. In this process, a cylindrical ingot of high-purity monocrystalline semiconductor, such as silicon or germanium, called a boule, is formed by pulling a seed crystal from a meld. 7,8 donor impurity atoms, such as boron or phosphorus in the case of silicon, can be to the molten intrinsic material in precise amounts in order to dope the crystal, thus changing it into an extrinsic semiconductor of N-type or P-type. The boule is then sliced with a wafer saw, a type of wire saw, machined to improve flatness, chemically etched to remove crystal damage from machining steps, and finally polished to form wafers. 9. The size of wafers for photovoltaics is 100-200 mm square and the thickness is 100-500 m. 10. Electronics use wafer sizes from 100 to 450 mm diameter. The largest wafers made have a diameter of 450 mm, 11, but are not yet in general use. Cleaning, texturing and etching. Wafers are cleaned with weak acids to remove unwanted particles. There are several standard cleaning procedures to make sure the surface of a silicon wafer contains no contamination. One of the most effective methods is RCA clean. When used for solar cells, the wafers are textured to create a rough surface to increase surface area and so their efficiency. The generated PSG, phosphosilicate glass, is removed from the edge of the wafer in the etching. 12. Wafer properties. Standard wafer sizes. Silicon. Silicon wafers are available in a variety of diameters from 25.4 mm, 1 inch, to 300 mm, 11.8 inches. 13. 14. Semiconductor fabrication plants, colloquially known as fabs, are defined by the diameter of wafers that they are tooled to produce. The diameter has gradually increased to improve throughput and reduce cost with the current state-of-the-art fab using 300 mm, with a proposal to adopt 450 mm. 15. 16. Intel, TSMC and Samsung were separately conducting research to the advent of 450 mm prototype research fabs, though serious hurdles remain. 17. 2-inch, 51 mm, 4-inch, 100 mm, 6-inch, 150 mm, and 8-inch, 200 mm, wafers. Wafer size typical thickness are introduced. 13. Weight per wafer 100 mm to 10 mm. Die per wafer 1 inch, 25 mm, 19602 inch, 51 mm, 275 m 196993 inch, 76 mm, 375 m 197224 inch, 100 mm, 525 m 197610 grams, 18, 564.9 inch, 125 millimeters, 625 m 198195150 millimeter, 5.9 inch, usually referred to 6 inch, 675 m 198314420 millimeter, 7.9 inch, usually referred to 8 inch, 725 m.199253 grams, 18, 269300 millimeter, 11.8 inch, usually referred to as 12 inch, 775 m2002125 grams, 18, 640450 millimeter, 17.7 inch, proposed, 19, 925 m342 grams, 18, 1490675 millimeter, 26.6 in, theoretical, 20, unknown 3427. Wafers grown using materials other than silicon will have different thicknesses than a silicon wafer of the same diameter. Wafer thickness is determined by the mechanical strength of the material used. The wafer must be thick enough to support its own weight without cracking during handling. The tabulator thicknesses relate to when that process was introduced, and are not necessarily correct currently. For example, the IBM by CMOS 7WL process is on 8-inch wafers, but these are only 200 micrometers thick.
Yes, I have a Danish video. I need to put public. It's 8:40 p.m. So let's put it public, so I not just lay here and reading like more, half an hour more. I have 4 videos. Danish, I need to put public. I need to spend 2 minutes. Okay, this was not ready. Yes, I have to wait. One of the videos not ready. Yes, we need to wait some minutes. So that's an important PDF. I have to read it again later. Yes, I'm finished eating my candy.
Weight half the wafer goes up along with its thickness and diameter. Historical increases of wafer size. A unit of wafer fabrication step, such as an etch step, can produce more chips proportional to the increase in wafer area, while the cost of the unit fabrication step goes up more slowly than the wafer area. This weighs cost basis for increasing wafer size. Conversion to 300 mm wafers from 200 mm wafers began in early 2000, and reduced the price per die for about 30–40%. 21. Larger diameter wafers allow for more die per wafer. Photovoltaic M1 wafer size, 156.75 mm, is in the process of being phased out in China as of 2020. Various non-standard wafer sizes have arisen, so efforts to fully adopt the M10 standard, 182 mm, are ongoing. Like other semiconductor fabrication processes, driving down costs has been the main driving factor for this attempted size increase, in spite of the differences in the manufacturing processes of different types of devices. Crystalline orientation. Wafers are grown from crystal having a regular crystal structure, with silicon having a diamond cubic structure with a lattice spacing of 5.430710 A, 0.54300710 nm. 22. When cut into wafers, the surface is aligned in one of several relative directions known as crystal orientations. Orientation is defined by the diamond cubic crystal structure of a silicon unit cell. Flats can be used to denote doping and crystallographic orientation. RID represents material that has been removed. Miller index with 100 or 111 faces being the most common for silicon. 22. Orientation is important since many of a single crystal's structural and electronic properties are highly anisotropic. Ion implantation depths depend on the wafer's crystal orientation, since each direction offers distinct paths for transport. 23. Wafer cleavage typically occurs only in a few well-defined directions. Scoring the wafer along cleavage planes allows it to be easily diced into individual chips, dies, so that the billions of individual circuit elements on an average wafer can be separated into many individual circuit